This is John Metz, the Warning Coordination Meteorologist with the National Weather Service Forecast Office in Corpus Christi, Texas. This presentation is titled Hurricane Basics, Critical to Survival. The topics we will cover today include hurricane basics, forecasting these storms, hurricane hazards, and hurricane history in South Texas. The hurricane is the most powerful storm on our planet. It is a low-pressure storm, with winds spiraling counterclockwise around a calm center. It isn't the eye of the hurricane that we worry about. The most destructive part of the hurricane is the donut region around the eye we call the eye wall. In this area, the wind speeds and storm surge build up the greatest. If this storm were moving from right to left across the screen, the right front quadrant with respect to its forward motion would be here. In this location, wind speeds and storm surge are the greatest in the eye wall. On the opposite side, winds and surge are typically reduced, but can still be destructive. Here is a snapshot of Hurricane Dean, which made landfall on the Yucatan Peninsula in 2007. Note the eye of this storm, the eye wall, as depicted on this image. Cancun, which is located about 100 miles to the north of where the center crossed the coast, did not go through the most destructive eye wall portions of the storm. The southern eye wall passed over the community of Chetumal, Mexico. The hurricane is a low-pressure storm that breathes in the very warm ocean waters. The inflow is in the lower level portion of the storm, and the inflow rises upward through the eye wall region, and the exhaust is out the top. High pressure actually sits on top of the hurricane, maintaining the exhaust mechanism. There is a sinking motion that occurs in the eye of the storm that causes compression and heating and typically results in a reduction or evaporation of clouds. Every hurricane is different. If you've been through a hurricane in your past, the next will not be the same. Every hurricane can vary in size, intensity, and the type of impacts you will feel. Here are two Category 5 hurricanes. On the left, Hurricane Floyd, a very large diameter storm, and on the right, Hurricane Andrew, a more compact hurricane. We know Hurricane Andrew dealt a very catastrophic blow to South Miami in 1992. How do we forecast the intensity of a hurricane? There are two primary elements that we look for when forecasting intensity: warm water and wind shear. This is a satellite depiction of warm water in the Caribbean and Gulf of Mexico. We don't just look at sea surface temperatures, that is, the temperature at the top of the sea. We need to know how deep that warm water is, because hurricanes are like mixers and can churn the warm ocean water some 300 feet deep. So we need that warm water to extend well below the surface. The warm waters are very deep across most of the Caribbean Sea, and these warm waters spill into the Gulf of Mexico through the Yucatan Channel. We call this the loop current. Wind shear is another factor that affects the intensity of a hurricane. This is Tropical Storm Claudette. Claudette was a long-track system that crossed the Caribbean Sea, briefly became a hurricane before passing by the Yucatan, and then weakened again as it crossed the Gulf of Mexico, taking aim on Texas. Note the center of the storm by this arrow. The white thunderstorm cloud tops you see just to the right of the center do not extend around the center of circulation because wind shear is blowing across the tropical storm from southwest to northeast. However, within 24 hours of landfall, the wind shear dissipated, allowing this system to quickly intensify into a high-end Category 1 hurricane. Tropical Storm Erin, that made landfall in Texas in 2007, was also plagued by wind shear. Note that thunderstorms are all located on the right side of the center of circulation. Hurricane Katrina emerged from the Florida Peninsula as a Category 1, moved over the very warm waters of the Loop Current, intensifying into a Category 3 storm within 24 hours in the center image, and becoming a powerful Category 5 within 48 hours on the image to the right. However, Hurricane Wilma is the all-time record breaker in the Atlantic hurricane basin. Wilma was just a tropical storm when folks went to bed that night, but woke up to a Category 5 hurricane. We've never seen a 100 millibar pressure drop before in 24 hours, and most of that occurred in a 12-hour period of time. The winds responded immediately to the pressure drop in this storm. How do we forecast where a hurricane is going? The National Weather Service launches weather balloons every day across the continental United States at 100 locations at 6 o'clock in the morning and 6 o'clock in the evening. These balloons ascend on a 2-hour flight to the top of the atmosphere, reaching 100,000 feet. And they are taking a picture of the atmosphere, measuring temperature, humidity, pressure, wind speed, and direction. However, we cannot collect the same information over the oceans because we cannot launch weather balloons for a lack of weather stations. The only way to determine the same information is by flying the hurricane hunters over the oceans and dropping instruments down to the water. GPS drop zones are dropped at various locations in and around storms. Here's the flight pattern from Hurricane Isabel in 2003. From this, we are able to determine the location of high and low pressure over the oceans and over the continental United States. And from here, we can determine the steering motions in the atmosphere and where the tropical storms and hurricanes may go. When a low pressure wave moves off the coast of Africa, and if high pressure was in this location, it would steer the storm in a clockwise motion, because the winds rotate around high pressure in a clockwise direction. And oh, by the way, the atmosphere is in constant motion itself. The highs and the lows may be moving and weakening or strengthening at the same time. If a low were to move to this location near the Leeward Islands and strengthen into a hurricane, where would it go? It would travel up and around the high pressure system because the steering motions around the high are clockwise. If, however, the high and the low pressure systems were moving in a westerly direction as the wave moved off Africa, and if it were to strengthen into a hurricane, it would travel in a path toward the U.S. mainland, a dangerous scenario. For Hurricane Dean, the high-pressure system was located over Bermuda, and Dean moved off Africa, traveled quickly across the Atlantic, becoming a hurricane before reaching the Leeward Islands. Unfortunately, Dean was steered in a westerly direction because the high-pressure system was moving to the west as well. How do we forecast hurricanes? The National Hurricane Center, which is part of the National Weather Service, is located in Miami, Florida. The facility is made from concrete and steel because Hurricane Andrew significantly damaged their original building. The National Hurricane Center operates on a $6 million annual budget. They are a 24-hour operation. They have 10 hurricane forecasters. They are a media magnet during the hurricane season for obvious reasons, and they average about 1.5 million hits on their website per day when a storm is threatening the U.S. mainland. The National Hurricane Center provides forecasts for all of the Atlantic hurricane basin and part of the Pacific. You may not know, but there is a National Hurricane Center in Hawaii as well that covers the rest of the Pacific Ocean all the way to Asia. Here's a photo from inside the National Hurricane Center. On this side of the glass, the media is usually parked waiting for an opportunity to interview a hurricane forecaster. On the other side of the glass, the hurricane specialists are working around the clock to forecast where these storms will go. Once a storm develops, the National Hurricane Center really gets busy, and they update their forecast 4 times per day. If you remember this simple phrase, 10-4 good buddy, you will remember the times the National Hurricane Center forecast is updated and on the website ready for you to view. But before the hurricane forecast goes out, a lot of information goes on behind the scenes. The process has actually begun 3 hours earlier. At 7 a.m. the cycle begins. The hurricane hunter has already been dispatched and is gathering information from within the storm. By 7:45 in the morning, the National Hurricane Center receives the latest aircraft data, and they run the computer models and prepare the forecast. By 9 a.m. the forecast is complete, and they coordinate with every forecast office around the Gulf of Mexico and Atlantic coastline. And by 10 a.m. all of the products are sent out to the public and available on the website. What kind of information can you obtain? Forecast text and graphics depicting where the storm is and where it's forecast to go, and the confidence levels and probabilities that the storm may take an alternate route. Hurricane forecasting improves every year. However, it is still not a perfect science. This is a graphic that depicts the National Hurricane Center's track error in the past 15 years. If a hurricane was sitting off the Texas coast and forecast to hit Corpus Christi directly in 24 hours, well, back in 1990, their average error was 110 miles. That red line at 1990 depicts 110 miles of error. That means the center of the storm could track 100 miles to the right, hitting Port O'Connor, or 100 miles to the left, impacting Brownsville, Texas. That's a lot of error for 24 hours out. But today these errors have been trimmed to less than 50 miles. Back in 1990, if a hurricane forecast 48 hours out said the storm would hit Corpus Christi, the average error was 200 miles on either side. Today that error has been reduced to less than 100 miles. And the 3-day error has been reduced from over 300 miles down to less than 150. So we've seen significant improvements. In fact, in 2006 we had the all-time lowest errors ever, but we still have a long ways to go. A hurricane forecast looks like this. This is a graph that you would obtain from the National Hurricane Center website, updated 4 times a day at 10-4, 10-4. You see a black line depicting the National Hurricane Center's best guess on where the center of the storm may track. However, as we just saw on the last graph, there are errors in track forecasting, and those errors are depicted graphically by the white error cone. This graphic means that the center of the storm could travel along the hurricane forecast track, making a direct hit near Palacios, with the eye wall region of the storm, and its catastrophic impacts affecting the 5 counties on the mid-Texas coast. You can also see the radius of tropical storm force winds extending as far right as Galveston and as far left as Corpus Christi. This forecast also implies that the center of the storm could follow along a path to the left, impacting Corpus Christi or some point on the lower Texas coast directly. This forecast also implies the center of the storm could follow along a path to the right, impacting southeast Texas or Louisiana. And in fact, that's what Hurricane Rita did. Forecast was off 170 miles, but still within the error cone. 2/3 of the time, the center of the storm remains inside this error cone, and 1/3 of the time it tracks outside the error cone. The error cone means that anyone within that area should prepare as if a direct hit could occur. Hurricane Dean's initial forecast indicated the center of the storm would cross the Leeward Islands and make landfall somewhere on Central America or emerge into the Gulf of Mexico. But as time progressed and Dean became a powerful Category 4 storm, the forecast called for the storm to pass south of Jamaica and impact the Yucatan Peninsula. But the 5-day error cone still indicated that someone in Mexico or Texas could receive a direct hit from this storm. As we move to Sunday, August 19th, Hurricane Dean was then taking aim on the Yucatan Peninsula, and the forecast track was shifted further south. At this point, the error cone was well south of Texas, and our threat was greatly reduced. This was the weather pattern in the forecast maps for Hurricane Dean, showing that high pressure was parked to the north of this storm, and Dean was steered on a westerly direction. These are the hurricane model tracks as well, showing you all of the different computer model runs for Dean, and showing you the level of uncertainty. There is pretty good consensus that the track models were taking Dean toward the Yucatan and then somewhere into Mexico.